Hi, everybody. Hope you're all doing well during this time where we're all staying at home and probably bored. So I'm going to try to give you a few things to do, maybe, or some things to learn as we go forward. But we're gonna try this out. I'm going to record some different lessons here, and I'll do it on a regular basis. We'll see how things go and how these work. To be honest, this is the third time I've restarted this recording. So bear with me at times. And hopefully this will help us continue on with some of our studies here as we move forward during this time. A couple things about this. The one benefit, as I'm going through some stuff, if you're not sure you understand, pause it, go back, that kind of thing. There will be times I may even tell you to pause and try a couple problems on your own. So you may want to have some paper there to try some things out, and a calculator today, because we are dealing with the natural logarithm and that button. The worksheet the other day, some of you might have completed. I know did complete. Some of you did not. And to be honest, there's a couple things on there that I'm going to kind of cover today, and I'm going to do a couple of the problems on the worksheet. And then I would suggest if you didn't quite finish it, or you didn't understand, or you got something wrong, go back and look at that. Contact me if you're having trouble at any time, either through Google Classroom or on our email. So I'm going to go through and try this out. We'll see how things go. There's definitely at times things kind of go glitchy here. I may pause it and then start back up this time. So bear with me this first couple times. All right. Okay. So let's try it out here. So one thing I didn't quite go over with you, even though it was kind of on the worksheet, but it was okay. We can kind of get through it. There are a few properties of logarithms, just basic properties. Okay, so we left off with logarithm. Remember, a logarithm is log base a of 1 is how you would read that. And so remember, if I was going to rewrite that, it would look something like, a to the y. It doesn't want to write y equals 1. Okay, so that's what I would do to try to figure that out. So what does y have to be? Well, the only thing it is a 0. So this is a property. So the property there that we're looking at is anytime you take a logarithm of 1, no matter what the base is, the answer is 0. Okay, if we use the same kind of logic here and change log base a of a into an exponential form, let's see if I can do that, a to the y equals a. So what does y have to be? Well, as you can see, I just lost something. I'm going to pause here. Back. Sorry about that. So if we have a to the y equals a, what does y have to be? Well, it has to be 1. Okay, so it has to be 1. The next properties here are a little strange. We'll come back to these later. We're not going to use them quite that much right now. But again, if I were to, for the first one in particular, change that to exponential, it's going to say a to the y equals a to the x. That looks a little strange. Really what that means is y equals x. What I really want you to see here later on is these are kind of opposite ideas. So, a to the x here, this part right there, a to the x is an exponential, and a log base a is a logarithm of base a. Those are opposite ideas. In a sense, what I'm going to get you to think about much later is they kind of cancel each other out, and we're just left with that x on top. So the same thing is going to happen here, because this is an exponential and then this is a logarithm. They're kind of opposites x. So don't get too hung up on that one right now, because we're not going to quite use that, but I bring them up as properties and we'll come back to them later. Okay. And then the last one, number 4, is pretty self-explanatory. I think most of you already kind of caught on. If I have two logarithms equal to each other, the same base, then that means what their logarithms are or taking of, they have to be x equals y. They have to be equal to each other. Okay, and another way we'll look at it is they kind of cancel each other out and they drop off. Okay, so we'll see that as well. All right. So that's kind of looking at, the properties there. And I wanted to cover that kind of thing. And we do have a few examples to look at in terms of that. I got to get out of this. I'm going to pause again. Sorry. I'm back. I'm sorry, but we'll get through this, though. I'll figure it out eventually. By the time I get this all figured out, we'll be back in school. So maybe I'll just continue to do this. I won't be in the classroom. I'll just do it from out in the hallway or something. All right. Anyway, so this is kind of using the properties here. The basic idea, you could solve these without the properties in a sense. Like the first one is log base 5 of 1 you know, what I want you to start thinking about, what that means is 5 to what power gives you 1? Well, that has to be 0. Okay, so that has to be a 0 that we're dealing with for the answer. Again, you could, if you want to, say equals y, and I'm going to do it off the side here. I'm going to write 5 to the y equals 1. What does that have to be? So you can think of it that way as well. Next one, number 2, is using the property we're taking log. I use crazy numbers here because log of the square root of 11 of the square root of 11. The point is, anytime you take the log of the same thing, the answer is just 1. Okay, it's just 1. All right, so that's the point of that idea there. Number 3 is kind of using the 3 and 5 are using that one property there that I said to you. We're not going to use quite that much, and it's kind of a canceling out. I want you to kind of think of it that this stuff kind of cancels stuff out, and you get 30. Okay, so that's what I want you to kind of see. I'm going to jump down to number 5 and kind of the same thing. These kind of cancel each other out, and you get x. Okay, don't get too hung up on that. Like I said, we'll come back to that probably next week sometime. And then number 4, these are both taking the log of base 2 of two things, so that means this x has to equal 3. I think that one's pretty self-explanatory. Most people kind of understand that. Okay? All right. What I want to jump to now, and this is where you may need a calculator as well, okay, is I want to jump to dealing with the natural log. All right, so this right here. Okay. So the natural log is a pretty important one. Remember before we left, we were talking about e, right? I remember e was this number, what was that, 2.71, blah, 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 whatever that is, all right? But it's an e button on your calculator, right? And we called it the natural exponential function, but this is the natural logarithmic function, all right? And so it's log base e, but we don't write it as that. We write it as ln. Okay, so we say ln of x. So when you see that, that means this, log base e. If you look on your calculator, there should be an ln button, all right? And that ln just means that we have a logarithm with base e. It's just a shorthand, kind of like when we did log base 10, we didn't write the 10, okay? And so that's all it means. The reason ln, I think it has something to do with French. It's like logarithmic de naturel, so they put ln instead of nl, okay? But that's why we have an ln, and that's what that means, okay? So when you saw those things on that worksheet, it just meant base e, all right? So, you know, we have a base 2, we have an ln, it's a base e, all right? So the next part here is really just using a calculator. So I'm going to show you the first one. So if I say ln of 73.25, I'm going to go to a calculator, okay? And I'm going to go ln, and then I'm going to go 73.25 equals, and I get that, 4.294, okay? So 4.294. Oh, this is hard to write. I don't have my normal pen. All right, so I would suggest right now take a moment and pause. Okay, I would pause it and I would try the next 3 here and see what you get. All right, so I'll go ahead. I'm going to actually pause it too, so I'm going to write down the answers and then come back to the answers. Okay, we're back. Here's the answers. So number 2, if you typed in ln of 0.4, you get negative 0.916. Number 3, you should got an error of some sort, so that's why it's no solution. Remember, we talked about that you can't take a logarithm of a negative number. It doesn't work. Remember, if we think about this, and we were going to write this as an exponential, this would be e to the y equals negative 2. Well, what does that mean? That doesn't mean anything. There's no way to put an exponent on that to make it a negative, so this one does not work. Okay, so this one won't work. Number 4, you have to be a little careful. I just put a crazy thing there just because you take logarithms, sometimes natural logs of crazy things. So it should look something like that. If you notice, I'm taking the ln of 2 plus the square root of 3 in there. You should get 1.37 in this case. All right? Okay. So next thing we want to look at is the properties that we just started off with. But in this terms, we're going to do it in ln's, in logarithms, okay? And it's, or natural logarithms. It's the same thing, though. So ln of e, or ln of 1, is going to be 0. Remember, what does that mean? Well, ln of 1 is the same thing as saying log base e of 1. So that's e to the y equals 1. What to the e to what power gives me 1? It has to be 1. Or sorry, it has to be 0. All right, to get that 1. All right, so you have to remember that. So that's the idea here. The other thing with these properties and these problems coming up, you could type that in a calculator. You could type in ln of 1 and you will get 0. And if you type in the next one, ln of e, you're going to get 1. Okay, so the ln's are nice in that sense because you can use a calculator on all of them, whereas the other properties, until I show you how to use the calculator and things, you can't. These would be those cancel out properties. Remember I said, so these will both be x, and then the last one is x equals y. Okay, so if we then take a look at the next, using those properties to kind of answer a few questions here, I'm gonna ask you to pause, I think, and why don't you try to answer these 4. You could either use a calculator or you can use the properties. Okay, so take a moment. I'm actually not going to pause. I'll just wait here a minute and give you time. All right, so for this one here, because this is ln of e to the 1/3, it's kind of like that canceling out property. All right, your answer is going to be 1/3. Okay, this one over here, it's another like canceling out. You get 8. All right, so this one, this is 15 times ln of 1. All right, so 15 times ln of 1. Well, if we use the properties, ln of 1 is 0, so this is 15 times 0. That's supposed to be a multiplication, so that's going to give you 0. Same thing here, this is 6 times ln of e. Well, ln of e is 1, so 6 times 1 is 6. All right, hopefully that makes sense. All right, again, you could just type that in the calculator and you will get that answer of 6. All right, so you're going to try a few of those. All right, the last thing I want to look at is a couple of the problems from the worksheet here. And this video here, I only got a few minutes left, so we're going to try to go through these. So this one here, log base 5 of 25. Again, what could we do? We set that equal to y. All right, so that's 5 to the y equals 25. So the only thing that works there is 2. Okay, now 32 is a little trickier. All right, this would be 5 to the y equals the cube root of 25. All right, so we got a little bit of a challenge there. So what we have to do is we got to change everything in terms of a y. All right, or sorry, not in a y, in terms of a 5. So the first thing I could do is, this is 25 to the 1/3. Remember we talked about that. And then I'm going to go one more step. I go 5 squared to the 1/3. And then when you have a power to a power, we're going to have 5 to the 2/3. Because when you do power to a power, you multiply the powers. So then that means that answer is 2/3. All right, I'm gonna pause the video. I'm gonna stop the video here. I'm gonna create another one to finish these other ones and talk about a couple of things that I have to add. Unfortunately, this software I'm using right now only has a 15-minute max on the videos. So you know, like I said before when we started this, you know, this is a work in progress. We're going to figure this stuff out. Maybe in the future I'll do something here so we don't have to do this, but I'm going to do that right now. So I'm going to stop the video here. And then there'll be a second one along with this that you can watch. Okay? I'll see you in a bit.